Good morning children, this is Latha. Welcome to class 6 IIT Physics class. Children, we are discussing the chapter kinematics, is it? And we are at the end of kinematics. Last class we discussed already the third equation of motion, that is v square minus u square is equal to 2as, is it now? We discussed the third equation of motion, v square minus u square is equal to 2as. We already derived the equation and then we saw some numericals also based on the third equation of motion. Okay na children? So the three equations of motion, the important three equations of motion are, first is v is equal to u plus at, then second is s is equal to ut plus half at square, and third is v square minus u square equal to 2as. The three equations of motion. Clear? Now children, we already completed the kinematics chapter, and at the end now we will discuss some special cases of equations of motion which we already discussed but still together in one place we will discuss all the special cases of equations of motion. So this class is going to be very important. You must understand this and remember this. Okay, it will help you a lot in the future. Okay, so you have to watch this class till end, and minimum 3 times you have to see this video again and again, then only you can understand it and remember it for a long time. Okay children, so let's start today's class. So special cases of equations of motion. Okay, special cases. So the special cases means what here? The equations of motion, the basic form of equations of motion, how changes under some cases, that one we will discuss now. So already the three equations of motion I said now. First is v is equal to u plus at, second is s is equal to ut plus half at square, and third is v square minus u square equal to 2as. Is it not children? Now we are going to see the special cases. So the first case is when a body starts from rest, initial velocity is 0, u is 0. Okay, whenever a body starts from, a body is in rest position, suppose you can see this ball. Okay, this ball is in rest position. A state of rest means there is no movement, no motion. Okay, ball is not moving, it is resting in one place. So as it is not moving, its velocity is 0. Is it or not? So whenever a body starts from rest, it is in rest, now it starts. So from rest, so its initial velocity means starting velocity is 0 because it starts from rest. Clear children? So initial velocity we always denote by small u. Remember, initial velocity small u, final velocity small v, a is acceleration, t is time, and s is displacement. Clear children? And these three equations of motion are only applied for which type of motion? When a body is moving with uniform acceleration. Again and again I discuss this thing, this condition. Okay, you have to remember this. These three equations of motion only applied for the body which is moving with uniform acceleration. Okay, now first special case is what? Whenever a body starts from rest, then its starting velocity, initial velocity is 0. Okay, so u is 0. Now how the equations will change? Let's see. First equation what I said, v is equal to u plus at, means first term u is 0, then becomes what? V is equal to at. Then S is equal to ut plus half at square. So first term is ut, as u is 0, so 0 into t 0, so first term is 0, so S is equal to half at square. Third equation, v square minus u square equal to 2as. So u square, u is 0, so that term not there, so it becomes v square equal to 2as. Got it, children? So if initial velocity is 0, when initial velocity is 0? When a body starts from rest, then its initial velocity, starting velocity is 0. So u is 0. So when we apply u equal to 0 in all these three equations of motion, then our equations will change in this way. Clear, children? Please write down this. Once again I want to tell you, you have to pause the video and write down, and after writing only you again continue the video. It is, maybe you are unable to write the notes, okay, while playing the video, because time will not be sufficient. That's why I am saying pause the video, write down, and then continue the video, because I can't focus for long time in same place. It will make the class again lengthy, that's why. Okay, so now we will go for the second case. So you can see, children, if a body is moving with a uniform retardation, A will be negative. So once again, the three equations of motion, I said what? Body must move with uniform acceleration or uniform retardation. Body must move either with uniform acceleration or uniform retardation. What is the difference? When the velocity of the body is increases with time, when the velocity of the body is increases with time, then bodies move, okay, acceleration is produced, okay. And when the velocity of the body decreases with time, suppose your destination came, you are going to stop your vehicle, what you will do? You will apply brakes. So when you apply brakes, what happen? Your vehicle will not stop suddenly. First its velocity decreases and then it stops. So when its velocity decreases, it means retardation, okay. So when the velocity of the body decreases with time, that is what? Retardation. So when a body is moving with uniform retardation, then acceleration A will be negative. So you remember, retardation is nothing but a negative acceleration, okay. Retardation or deceleration is nothing but negative acceleration, means A becomes minus A, okay. So now when we apply place of A, why? Because body is moving with uniform retardation, so A becomes negative. So in place of A, what we will use? Negative A. Then how the equations are changing? Let's see. First is what? V is equal to U plus AT. Now in place of A, minus A, then the equation becomes V is equal to U minus AT. Second equation, S is equal to UT plus half AT square. So as plus A is replaced by minus A, then the equation becomes UT minus half AT square. Now third one, V square minus U square is equal to 2AS, okay, or V square minus U square equal to 2AS. So when you will shift that side, U square becomes V square equal to U square plus 2AS. Now here A is what? Replaced by minus A, then it becomes U square minus 2AS, okay. So V square is equal to u square minus 2as. Clear children? Write down. Over. Now third case, if a body falls from rest freely under gravity from a height h, then u is 0 and acceleration a is replaced by g, that is acceleration due to gravity. Clear children? If a body falls from rest, so body falls from rest means a rest, when body starts from rest, so initial velocity 0 according to first case. Already we discussed, whenever a body starts from rest, so here also body falls from rest, so initial velocity is 0, that is clear. Next is what? Body is falling freely under gravity. Whenever a body falls freely under gravity, that time acceleration is replaced by acceleration due to gravity. A is replaced by small g. G stands for acceleration due to gravity. Its value is 9.8 meter per second square. This is in SI system, whereas in CGS system 980 centimeter per second square in CGS system. Got it? So if a body is falling freely under gravity, then A is replaced by G. Okay, and as the body starts from rest, so initial velocity is 0. Now what is the height? Height is given h. Okay, now see how the equations changes. First one, v is equal to u plus at, so u is 0, so first term is 0, so v is equal to at. Now a is replaced by g, so v is equal to gt. Okay now children, v is equal to u plus at, u is 0, so v is equal to at. Now a is replaced by g, so v is equal to gt. Okay, now second one, s is equal to ut plus half at square. Now s is what? Displacement. So here what is the displacement? Height. So s is replaced by h. S is replaced by h. First term ut, u is 0, so 0 into t 0, first term becomes 0. Now second term half, a is replaced by g, so gt square, so h is equal to half gt square, that is h is equal to half gt square. Third equation, v square minus u square equal to 2as. So first v square minus u square, u is 0, so this term is 0, so v square is equal to 2as. A is replaced by g and s is replaced by h. Remember, a is replaced by g and s is replaced by h. So becomes v square equal to 2gh. Clear children? Please note down this. Over. Now in this same case, one more is there. If the initial velocity of fall of the body is u, then here first case is the C case, In that first point what we discussed, that body starts from rest, falls from rest. So as body falls from rest, initial velocity is 0. But here is what, body is not falling from rest. Okay, second case is what, body is, its initial velocity is given u. There is some initial velocity. Body is not falling from rest, having some initial velocity. So we will take initial velocity u. So if we will take initial velocity u, means initial velocity is not 0, then the equation becomes v is equal to u plus gt. So only a is replaced by g. So v is equal to u plus gt. S is equal to ut plus half at square. S is replaced by h and a is replaced by g. So becomes h is equal to ut plus half gt square. Okay. Next, v square is equal to u square plus 2as. As v square minus u square equal to 2as, but u square when you will shift that side, it becomes v square equal to u square plus 2as. So a is replaced by g and s is replaced by h. Then it becomes v square equal to u square plus 2gh. Please note down this. Okay. Now children, next fourth case D. If a body is thrown vertically up with an initial velocity u to a height h, there will be a retardation. So if a body is thrown up vertically, okay, body is thrown up, so body is going up. Remember, whenever you throw anything up, means it is going away from earth. Remember children, whenever we throw anything, any ball, anything, we throw up, upside, means it is going away from earth. When it is going away from earth, its velocity is going on decreasing. Okay, velocity going on decreasing. So initial velocity is given u. What is the initial velocity of the body? U. And it is thrown vertically up with how much height? H. Okay. So there will be a retardation. Why retardation? Already now I said no. Retardation when the velocity of the body decreases with time, that time it produces retardation. Okay, velocity decreases. And here also body, when it is thrown up, means it is going away from earth. When it is going away from earth, its velocity going on decreasing. So produces retardation. So negative acceleration. Retardation is nothing but negative acceleration. And here, as the body is thrown up, means it is working under gravity. So A is replaced by G. A is replaced by G and what? Negative G, because retardation. I think you are understanding children. Whenever we throw anything upside, means away from earth, velocity decreases with time. So as the velocity decreases, produces retardation, means negative acceleration. Now body is working under gravity, so A is replaced by G, and here which G? Minus G. Got it? Now let's see how the equation changes. First one, V is equal to U plus AT. So you are having initial velocity U only given already. Now plus A is replaced by minus G. Okay, here given already. Plus A is replaced by minus G. Okay, so V is equal to U minus GT. Second is h is equal to ut plus half at square. So plus a is replaced by minus g. Already here mentioned a is replaced by minus g. So plus is replaced by minus g. So equation becomes h is equal to ut minus half gt square. Third equation is what? V square is equal to u square plus 2as. So plus a is replaced by minus g and s is replaced by h. Okay. A is replaced by minus g and s is replaced by h. Then the equation becomes v square equal to u square minus 2gh. Okay children, please note down this. Now next is what? At the highest point of reach, we are throwing the body up. So when we throw anything up, you say example, when you throw any ball upside, what happened? It will go to a highest point, a maximum point. After that, it will start again coming down. Is it or not? So when the body is thrown up, its velocity going on decreasing, and at the maximum height it reach, there the velocity becomes 0, and then after when it comes down, its velocity going on increasing. Clear children? Remember this one. Whenever you throw any body upward, its velocity going on decreasing. It reaches to a highest point. At the highest point, its velocity becomes 0, and then after it starts coming down, and when it comes down, that time its velocity going on increasing. Okay, so at the highest point of reach, the point where maximum height, up to where it can reach, at the maximum height the velocity, final velocity will be 0, and the maximum height it reached means h maximum. How can you find? U square by 2g. This one we can derive from the equation v square is equal to u square minus 2gh. See how? V square is equal to u square minus 2gh. Okay, so as here plus 2as should come. Okay, so plus a is replaced by minus g, plus a is replaced by minus g. Why? Because body is thrown up, body is going up. Okay, that's why plus a is replaced by minus g and s is replaced by h, and then the equation become v square is equal to u square minus 2gh. Okay, so here your final velocity is 0 is equal to u square minus 2gh. Okay, then u square equal to 2gh. Here h is what? Maximum height. So h maximum is equal to u square by 2g. Okay, so h maximum, maximum height is equal to u square by 2g. Okay, next is time taken by the body to is to the highest point. How much time taken by body to reach the maximum height? T is equal to u by g. U is initial velocity, u by g. Okay, I hope you are writing also. Once again I will tell you, you have to pause the video and write. After writing only you again continue the video. So maximum height, what is the formula we got? Maximum height is equal to, whenever you throw a body up, it can go a maximum height. That maximum height, how to find out? U square by 2g. Means you must have the initial velocity of the body. Okay, so next, time taken by body to reach the highest point. How much time taken by body to reach the highest point? T is equal to u by g. This one also we can get from the equation v is equal to u minus gt. How v is equal to u minus gt? Because v is 0, at maximum height final velocity is 0, so v is 0. So 0 is equal to u minus gt, means u is equal to gt. So t is equal to u by g. T is equal to u by g. Okay. So time to reach highest point, t is equal to u by g. The same will be the time it takes to reach the highest point. The same time will be that it takes to come back to the initial point after reaching the highest point. Okay. What time, whenever you throw a body upwards, what time body takes from ground to reach highest point, that much time only body takes from highest point to come back to the ground. Children, please understand. Suppose a ball you are throwing up. How much time ball takes to reach the highest point? That much time only ball will take to come back to the ground. So time of ascent and time of descent both are same. Time of ascent means time to reach highest point. Time of descent means time to come back to the initial point. So time of ascent and time of descent both are same. So total time of journey means time plus of time of ascent plus time of descent. So that is called total time of journey, that is t dash is equal to 2t. Okay, here we calculated t now. This is from initial point to highest point. Then highest to again come back the ground also same time only. So t plus t, 2t. Total time of journey is 2t. T is how much? U by g. T is how much? U by g. And 2t how much then? 2u by g. So total time of journey becomes 2u by g. Time of ascent is equal to time of descent is equal to u by g. Whereas total time of journey t dash is equal to 2t, that is 2u by g. Clear children? Write down. Now next is total distance travelled. How much when you are throwing a body upwards? Total how much distance travelled by the body? From ground to reach highest point and from highest point to come back to the ground. Okay, so H maximum is double. H maximum we already calculated now. H maximum is equal to what? U square by 2g. So here this total distance travel is H dash, that is 2 times of maximum height. So 2 into what is H maximum formula? U square by 2g. U square by 2g. 2 cancel. How much we got left back? U square by g. So twice of H maximum is formula is U square by g. So total distance travel, initial point to maximum height and maximum height to again initial point. So that is total distance travel H dash, that is 2 times of maximum height is equal to what formula children? U square by g for the body thrown up with a velocity u. Clear children? Today we discussed some special cases of equations of motion. Once again, what are the equations of motion? First equation of motion is v is equal to u plus at. U is initial velocity, V is final velocity, A is acceleration, S is displacement, T is time. First equation of motion is V is equal to U plus AT. Second equation of motion is S is equal to UT plus half AT square. Third equation of motion, V square minus U square equal to 2AS. Then after we saw some special cases, under that the equations of motions are changes, modifies. Okay, so that special cases are very important. It will help you a lot in the higher classes in the physics. You have to remember this one. So once again I will tell you, you have to complete the notes. While playing the video only, you pause the video, write down, and then again continue the video. Must maintain the notes neatly, worksheets you have to do, and you have to reading work minimum 3 times. Classes also till end 3 times you have to watch, then only you can understand the concept. Very soon I am going to conduct the exam on the measurement chapter. Already measurement 3 concepts test is over. Again next concepts I will conduct test. Okay, so the next class, children, I will say once again, here we completed kinematics. Okay, kinematics is over now. Now next class we will do the revision, okay, for the test, and then after test will be there, and then only we will again further we will move. Okay, so this is for today. Thanks for watching.